pakai. Alright, so we continue with example 3. So example 3, the question given fx 0 and x. So they have two functions, so that means it is a piecewise function. And then the interval is from negative pi until pi. And they have also given your period here, so 2 pi. So the period here is 2 pi. Okay, so the question asks you to find the Fourier series for the given function. Alright, so step number 1, you need to check it's even or odd, right? So since you have a Fourier, you have a piecewise function here, so it's more better if we find the function even or odd by using graphical. Okay, so you have two line. Okay, they have two functions here. For the first one is fx equal to 0 from negative pi 0. So here is negative pi 0. So your fx is 0. 0, okay? 0. So it must be a horizontal line. Alright, from negative pi to 0. And then the second one is from is x is from 0 until pi. So 0 pi is here. So the graph of x, how the graph of x looks like. So you can refer to your previous example. We already do it before. Okay, so this is the graph of x. Okay, so it must be this one. Okay, this one 0, this one is x. Alright, so then what we do next is y. Okay, we can see that I have 2 pi and negative 2 pi here, even though actually the interval is just pi, right? But you need to make it's double. You need to refer to your period. So you just repeat the same shape. Okay, this is 0 pi, right? Like this, right? So you just continue from pi here, this one, so this one, this one. So this is the perfect or the complete graph. So but our main is this one. Okay, this one, because the interval is from negative pi pi. So now check whether this function is odd or even. Is it symmetrical on y-axis or not? No, right? If it's symmetrical on a y-axis, there must be have somewhere here the graph, but we doesn't have this shape or this line. If the shape or if the function is odd, it must be symmetrical at origin, so therefore the shape or the line must be somewhere here, but we doesn't have this line. So what's the answer for this one? Because this is the line, so you cannot prove that this shape or this line is symmetrical about y or about origin. Therefore this function is neither. So this is a neither function. This is an example of a neither function. Means that it's not even and also it's not odd. Okay, so how to answer this one, right? So what we do is, so same thing, but now this is neither, right? So means that, okay, means that they have no coefficient Fourier equal to 0. Means you need to calculate all. You need to calculate all. If before this, if the equation is even, you just calculate you just calculate a0 and n, right? Your bn is 0. If the function is odd, so you just calculate bn. Okay, a0 and n is 0. But now it's a neither, so they have no coefficient. They have no Fourier coefficient that will be 0. So that's mean you need to calculate all. So you need to calculate all by using the first type. Okay, the first type lah, because the function is a piecewise function, right? So fx dx, okay, 1 over L lah. So you just refer to the formula before this. So you just answer all this. Okay, just follow the steps on the previous example, so you can do it. So the last one, okay, don't forget to substitute back in this. Okay, don't forget to substitute back in this equation. So for neither, you have an extra works to do lah. Before this, you just ignore 0, 0, right? So for neither, you need to calculate all. Okay, then you substitute back into the equation. So they have the answer lah. Okay, so I will give you the answer. Okay, I will give the answer for this question. So you do it by yourself. Okay. So the answer for an, okay, sorry, a0. Okay, your answer for a0, you should get pi over 2. Okay, and the answer for your an, you should get 1 over n pi square. Okay, pi square, not n pi bracket square. Pi itself, sorry, not pi, is n square pi, sorry, n square pi. And then in the bracket we have negative 1 power of n minus with 1. Okay, this is your an. And the last one is your bn, is negative 1 over n in the bracket power of n. So a not an and bn, so substitute into the equation back, so you will get the answer. Okay, alright. So we will finish for this series, but they have another one subtopic, but I will just brief. Okay, I mean because it's similar, like I said before, half range series. Okay, like I said before, right, half range series is a part of a full series itself lah. Okay, half range series. Okay, so this is another one topic, but it's similar. It's nothing much that different with the Fourier series. Okay, Fourier series we can call it as a full Fourier series. So if you still remember before this, I said that the Fourier series, the interval must be from negative L x until L, right? So this is the full one, or the before this we do this example lah. Okay, negative L. So what's mean by half range series is the interval is cut half lah, maksudnya half. Before this is from negative 1 until, sorry, negative, let's say negative 1. So now for half range series, it will be from 0, 1. Okay, so you just draw the graph. Okay, the graph of the shape lah, the shape. Graph of the function. Means, okay lah, I give you example. Okay, let's say you have a function f(x) equal to what? Equal to modulus x. Okay, modulus x. So then the limit is just only 0 x 1. Okay, 0 x 1. So how the graph of this modulus x looks like? So is there fx? This is x. So you just cover, or you just draw this line. Sorry, you just draw this line because it's just cover positive part. So then how to know this one is odd or even? Because you cannot conclude this is symmetrical on y or symmetrical on x. So for half range series, what we need to do is you need to do it both. You need to do it for what we call for the even and also for the odd. So they have a specific name. Okay, they have a specific name for half range series, which is half range cosine series. Okay, and half range sine series. Okay, so what does it mean? Okay, it means if the function you want to do it for the even, so the name is cosine. For the odd, the name is sine. Half range cosine and also half range sine. So it's I mean basically it's similar. Just on the interval. Okay, just on the interval is cut into half. Alright. Okay, so you can refer to the slides. Okay, if you want to do more exercise and so on, you can refer to the slides, or you can just Google. Right? Okay, so we are finished for the Fourier series chapter. So we have another one chapter that we left. So before that, yeah, you can try to find out another exercise and so on. And for the next week, okay, we will having our second quiz for the virtual class lah. Okay, and then the second quiz is regarding this topic. Alright, okay, bye.